So, hello everyone. Um, I don't. I think it's safe to assume that most people these days have a mobile device. Depending on your preference for device operating system, yours could look something like this, where you have the, I guess, not so infamous anymore notch. It's not ideal, but it is what it is. Or you could have something of the Android variant running on various device types and various versions of Android that are derivative from that. Um, be it iPhone, Android, I think it's pretty clear that we all owe a lot of what mobile has become to this. This is the original iPhone, released all the way back in 2007, 2008, I believe. I was, I had no idea that this would become a thing. I thought that this was just a passing fad, and that who would ever want to use a touchscreen for a phone. But I am happy that I was proven wrong. This announcement, I think everyone can go back and watch and see in retrospect what the iPhone originally promised and what we got today. Way back when the iPhone was announced, we were told, hey, you're going to be using the web to build all your mobile apps. We don't have a dedicated SDK or platform for building these apps. The web is a powerful and feature-rich platform, and you can build lots of complex UI that can provide a lot of value and features for your users by just knowing a little bit of HTML, CSS, and JavaScript. Developers absolutely hated it. They did not like that idea, and Apple quickly did some course correction, and we now have this budding platform of iOS development. We have things like Objective-C for the older version of development, now Swift, and even more recently, things like Swift UI that we can take advantage of to build our apps. Great ecosystem. It's got a lot of cool features, but it's also a siloed ecosystem. Once you have an app written in Swift UI for iOS, getting that platform outside of Apple's ecosystem, getting that app and that product outside of Apple's ecosystem is going to require you to essentially rewrite your entire app for this new platform. This leads us to Android, where Android is traditionally Java, more now Kotlin, where you write your app inside of this platform, and that's where it's going to stay. It's kind of something that we all know, but maybe don't realize, is that every time we see an app that comes out for iOS or Android, there's either two code bases going on there and dedicated teams working on those apps to maintain it, add feature parity, and provide the same level of polish and same experience to both platforms. Maybe not something that we all want to deal with, but it is a fact. Now, smart developers kind of got together and realized that this was going to be a problem. They realized building for multiple platforms is expensive from a manager perspective. Hiring multiple teams of developers to maintain a separate code base is going to cost a lot. Maybe you don't have the budget for it. Maybe you're a small startup and all you have is at most, hopefully, a designer and a couple developers. It's expensive. It's time consuming as you're developing. Maybe the iOS team finishes first and that you now need to wait for Android. Unnecessary pressure on the Android team just because one team finished before. It's unnecessary. So these smart developers came together and they figured out ways to bridge the gap between each of the platforms and figure out a way to have a common abstraction that can be used to target both iOS and Android. This has led to the idea of cross-platform development, where we have a single abstraction. Developers can use that abstraction to deploy to iOS, Android, various other platforms, all by using a higher level abstraction for their API calls. You can develop for iOS, Android, call the camera, and know that it's going to perform the same way. So let's take a look at what this abstraction has evolved into, because it's been some time, and figure out what is, the new mobile stack for 2022. So my name's Mike Hartington. I'm a developer advocate at a company called Ionic. You can find me everywhere on Twitter. Chances are you'll see pictures of guitars, cats, dogs, furniture that I'm building. I love to make stuff, whether it is mobile apps or music or furniture or guitars. I just like to do stuff. Busy, keeps me busy. But I also like to focus on how this stuff works and understand the nuances and details to better explain it to folks. Let's dive into that into that cross-platform development story. Now, when we think cross-platform development, we typically think about this idea of writing once and running everywhere. The idea that I should not have to duplicate code or duplicate effort on my part to be able to ship something to multiple platforms. They're common enough abstractions and common enough platforms that there should be a way to write it once. This leads us to abstractions around the native features, not necessarily the UI implementation, but being able to abstract away common actions that get performed on these native devices. For instance, having access to local notifications is a fairly typical feature of native apps. What is a way that we can provide that in a streamlined API that automatically knows which platform it's on and update and call the right code accordingly? But me, as a developer or the consumer user of this code, I don't need to really care about the platform's specific details. That can all be handled behind the scenes. And when we have this one code base or this write once kind of mentality, well, we can be a little bit more agile about where we move. We can have our code base solidified, wrote down, deploy to iOS and Android almost simultaneously. A new platform comes around. Say we want to target Electron or a dedicated Windows environment. We can pick and choose and move to where our users are going to and target those platforms without having to rewrite our entire app, create a new team, or go out and hire more people to be developers for that platform. It's a lot more streamlined. So we're going to look at a few players here in this space, but I want to make sure that we're clear what we're going to be talking about. We're going to be talking about the stuff that we work on at Ionic. Briefly, just as a quick little aside, we're also going to mention this JavaScript framework called Angular. It's a framework. Not everyone is a fan of it, but we can swap Angular out for React or Vue. Angular is just what I prefer. And this last little piece is going to be the real important part. This is this one called Capacitor. Capacitor is going to be our real key player here, but let's dive into Ionic first. So Ionic is a framework that's been around for a number of years now, but it is a UI library for building UI for native and web. What you end up working with is a collection of components that can be deployed and consumed on various platforms that feel at home to that platform. So if you have a card, a button, a tab group, a collection of animations, they're all going to adapt to whatever platform they're on. And now I am on the web, I should look this way. I'm on iOS, I should look this way. And I'm on Android, and I should look this way. Not only will they update their looks and their styles, but they're also going to update their interactions. For instance, a button in Android has this very particular ripple effect, and it's a key design thing from Google's material design. We make sure to include that and provide the right ripple effect only for Android. iOS doesn't need that. Yes, you can hard code it to include that on iOS, but by default, we respect the platform's design language, and we think that you should as well. When you're going out and building these apps, we also integrate with all of the official tooling for these web frameworks. So for Angular, we're making use of things like the Angular CLI. For Vue, we're using Vue CLI and soon to be using Vite and all of the new features coming out from the Vue ecosystem, and React using Create React App. So you should feel very familiar and right at home with these with projects using Angular, React, or Vue, and Ionic. And it's highly customizable, so that way you can adapt any of the styles to not only look like a high quality native app, but also feel at home to your own design and branding. Make sure to include that you should have a designer on your team because they do amazing things. We also want to make sure that your design can be expressed in these apps and not just look like stock iOS or Android apps. There should be some character and some personality behind the designs. So the components range from things that are like this little badge on the first example. It's a very small self-contained component, doesn't provide a lot on its own, and it's almost like an atom. It's its own standalone thing. It's the smallest divisible part. These components can be composed together to create molecule components. If we think of this card, it's in the third image. It's includes a bunch of subcomponents that, as they all get composed together and are inside of a greater card context, it knows, okay, I need to adjust the styles slightly to accommodate for this form factor and this UI element. Components also include things like navigation, tab-based elements, everything that you would want to have from a UI library, and also a navigation system where you can have animations just already provided for you out of the box. So let's take a quick look at what some of this code actually looks like that developers are going to write. So we start off real simple. Most websites and most web apps and most native apps these days include things like a header and a content area, where there's going to be some stuff that exists at the top level of our page or our viewport, and we're going to have a scrollable content list later on. Well, let's focus on the header real quick. Headers are pretty boring by themselves, so let's give it a toolbar where we can say there's a title, and the title is notes. We'll have this whole thing self-contained. It knows which platform it will be on, so it'll be adjusted either to the start in left or right. It'll be on the left side, and it will be on the right side in right to left. Further along, we can include a collection of buttons that will also adjust their position based on the direction attribute that you apply. So if you are in left or right, and over here will indicate that you are on the right side. Right to left, and will equal left. And then we can include a collection of buttons and icons to provide some interaction into our app. All of this is very independent, doesn't know what platform it's on. We just know that I have a button. It could have more buttons down the future, but I have a single button right now. It has an icon inside of it, and it has a title and a toolbar inside of a header. Further on, in the content area, we know that we have a list of things that we're going to want to include. Want to render it, we're going to want to have all this. So inside of the list, let's just create an iterator. This is specific to Angular, so if you're familiar with React or Vue, it's going to look slightly different, but the idea is that we're going to have some data inside of our app. In this case, it's a list or an array, where we're just going to iterate over each entry and render out that entry. So we'll iterate over each one of them, render it out inside the Ion item, and altogether, this UI, without ever opening up the browser, becomes really easy to visualize all together. The code is pretty self-contained, it's easy to visualize, and it makes sense when you think about the tags that you're writing. So this is what we have so far. Let's go ahead and actually see this in action. So I have my app running on the right-hand side, and I have my editor here on the left side. I am using Vim. Save any judgment or comments for later. But let's take a look at this home page and look at the template that we have here. Now, we have a few more attributes going on here. We have this thing called translucent. We don't really need to worry about them, though. All we need to know is that as we look throughout the code, we can see areas where the UI is going to be reflective of what we have. So we have the content. We have the secondary header, which is a little peculiar. And then we have this ion item. Let's go back to that secondary header because we don't really see it here. It's kind of hidden away. But let's go ahead and inside of our DevTools, let's mimic an iPhone. We'll reload. And just to make sure that we can trigger it, let's go and render out 100 paragraph tags. Let's see. Okay, so that's not going to work, but we can go over here and we can start to see the simulation here. We have the second header, and if we were to have, say, let's try it one more time. Anyway, we'll leave onto it. What we have is a secondary header that feels at home for an iOS platform. As we start to scroll, what would happen is this would collapse and actually show in the top header bar. So already the UI here is pretty accommodating for the fact that different platforms have different design styles and that we should be supporting that. This button over here in the header also shows an example of some transitions that we could have created. So this is an example of an overlay component. iOS provides these out of the box with this little stacked card UI. And we can click in here. We could have a note. This is just using a typical web library called Quill.js. We can come over here. We can have item 1, item 2, item 3. We can select all those, just throw those in a quick little formatted list or an ordered list. Indent them if we wanted to. We have a lot of flexibility here. This is just pulling in a random library from npm and just using it inside of our project. Now, when we go to click the save button, we get prompted to say, hey, what should we name this? So we'll just call it my note. We can click save. And well, nothing really happens at the moment. See, we've gotten down the visual aspect and the common UI patterns, but we don't have the native interactions done. And then this brings up the next part, adding those native features and how that's done. So this brings us to our second player in the space, and this is a project called Capacitor. It's something that we started a couple of years ago, feeling frustrated with existing solutions, and we wanted to take advantage of what native platforms provided developers and introduce those to web developers in a pretty nice way. So it includes this web-centric API. If you want to, for instance, access a file system, you have a single API that you can just import into your project, like any kind of JavaScript module. And then you can call methods on that file system object and handle saving, reading, and writing files to the file system. To make sure that all this is possible, we try to stay out of your way and do not introduce custom tooling. So if we are including, say, third-party native SDKs, you're going to be using the native tooling that those platforms provide. So SDK updates, project maintenance, all is done by the native SDKs and the native tool chains. So it feels great for staying up to date with updates from Apple and Google. And we try not to hide those native projects. So if you're a web developer, you should feel familiar to how the code works. And if you're a native dev, you should feel familiar with the native project setup. So native devs can take advantage of this too by collaborating with their web counterparts and getting features integrated like push notifications. Now, I'm a big fan of architectural diagrams, and in the most basic sense here, what we end up having is this web app that we run right in JavaScript. This web app gets packaged inside of a capacitor runtime, which will load and run the app, but also provide a top-level execution context, so that way it can talk to this bridge layer. So in my web app, if I call get picture or file system read directory, the runtime is going to talk to the bridge and figure out, hey, bridge, get me the file system for this native runtime. That could be Android's file system, or that could be iOS's file system. It'll go ahead, call those file systems, return any data, serialize it, and then send it back to the capacitor runtime, which then returns that data to your web app. In a nutshell, this is how this works. This is how a lot of projects work in this space. So this isn't too unsimilar to what other projects are doing out there. What makes it really powerful is that with this, not only can we target iOS and Android, but we can target the web without having to introduce a translation layer. So that runtime can be swapped out on the fly, and we can say, I am on the browser, I'm in a browser, use this implementation, or I'm on Android, use this implementation. So now we can target all these platforms without having to have any conditional logic in our code to check for the platforms that we should be targeting. This is really, really powerful stuff. Some things to just keep in mind. Capacitor itself is a separate project from Ionic, and therefore you don't need to use the two of them together. I think you could and you should, but if you're a team that already has your own design system or design UI, you could use that. Or you could just use Ionic if you want. The API, while we make use of the standard web versions of them under the hood, they're not going to follow those APIs one-to-one. We're going to provide a nice abstraction on top of it. And, you know, the features are going to become available as soon as the app runs, so you don't have to worry about any delays or slowness there. So let's see this in action. Let's go over to our homepage logic. I know that we need to have a way to load up some stuff here. So let's go ahead and import a package. This is one called capacitor file system. It's going to give us a file system access, pretty self-explanatory. And we're going to use this request permissions API to go ahead and say, hey, can I read the file system? If the user says no, we no op out of there and reject the promise, and then we're fine. But we should be able to request permission for it for privacy concerns. And then we're going to init this file system by saying, make a directory if it doesn't exist, and then read a directory. So that way we can have a nice stored location for all of our data. Now this make directory is as simple as saying file system make dir. If anyone's ever run make dir on the command line, this is essentially the same thing. We're going to create a documents directory, and we're going to create a folder called notes. This is where we can store all of these notes for later reference inside of our app. When we want to read that directory, we essentially just call filesystem.readdir, give it the same data, directory of documents, and read the notes directory. And we're going to get back an array of files that could be in there. We'll do a quick little sorting algorithm here just to make sure that we are sorting things properly. But once all this is together, we now can read and load data from our file system. Let's go ahead and save this and see what notes I saved in there. Perfect. I didn't save any notes, so let's go ahead and add some notes in this part. So let's go to the edit page. And same thing, we're going to start off by including the file system and including a few other enums that come from the capacitor file system API. See that when this component is created, we're going to go ahead and we're going to start to read data from the file system based on a name property that gets passed into it. We'll make sure that we're getting it from the documents directory and that we're in UTF-8. Once we have all that data loaded, we'll just set the content for this component to be that data. Now, as we go throughout this, we want to make sure that we can also save and write this data to the file system. So we'll have this write file system where we'll make sure that we create a new file, have the data either be an empty string or the content that we have already written ourselves. Again, saving it to the documents directory and that we are using UTF-8. To delete it, we do essentially the same thing. We grab the file itself and then we just call delete file. Pretty self-explanatory. Now, all this together, we now have a system where we can say, create a new note. I'm going to say, hello, SPOTcon. We will go ahead and we will just save. And then my first note, save again. And hey, my note's already in there. I can go ahead and open it up again, make some more edits, make sure that I am capitalizing the correct letters instead, save, and everything's up to date. This is really great in the browser, but we want to be talking about mobile. Well, if all of this stuff is applicable to different platforms and the native stuff can be swapped out without having to rewrite our entire app, how can we deploy it to a native device? Well, we can go over here and then I'm going to stop my dev server real quick. Just do a quick little build. npm run build. Doesn't matter what build system you're using. This is just going to take a moment. Cool. Took about 10 seconds. And then we can run this capacitor command to sync the native, the web assets and the native assets with our native project. So it'll copy everything over. It'll update all the dependencies and native code base using something called CocoaPods. So again, using the native tools that everyone is familiar with. And it'll update the iOS project in about 7 seconds. From here, we can open up Xcode in a simulator, and let's just run this. And you notice that this is just a full-blown native app. I have access to all of the app delegate methods if I wanted to modify this. I could go ahead, I could modify the launch screen storyboard if that's something I want to do, or just modify the main storyboard. Maybe I want to introduce a new view controller beforehand. Either way, I have full access to this project's native assets. So let's go ahead and run build. It'll only take a moment here. Xcode is actually cooperating here. Now, our app has loaded. I promised that the header was working, because here we can see that the UI blurs correctly and shows the new header. Now, we can go ahead, add a new note. Hello from iOS Sim. We will save my iOS note. And I can save that, and the note is still there. Now, what's great here is that the mechanism for which this data has been saved here on iOS is completely different from the mechanism that it's saved in the browser. On iOS, this is using the native file system in the native app sandbox system here. So all these notes are secure and isolated to this app. And then in the browser, these get stored inside of an IndexedDB database that we can limit access to one URL. So only that main app has access to it. It's really, really nice. If we want to swap this out for, say, a file system API that comes to the browser in the future, we can do that as well. But now we have something that works for multiple platforms with only having to know one API. So let's kind of get back to the slides and just wrap it up real quickly. Like I said, you could add this to any web project right now. If you have a interest in trying out the mobile the mobile platforms without diving fully into it, you just add the packages for our core and the CLI, and then run cap init to start up this whole process. It'll give you a configuration file, and then you'll be able to install not only iOS, but also Android. If you want to learn more about it, you could check out capacitorjs.com. We actually have just released a bunch of new plugins. One of the most highly requested one that people have wanting is a native Google Maps plugin. So definitely check that out. And then if you want to check out more on the UI and visual side, check out ionicframework.com. We have a whole collection of documentation and reference examples that you can get started with. So wrapping up with some parting thoughts, if you are interested in the UI aspect, check out Ionic. It provides a lot of those common building blocks that developers have wanted for years that can adapt into web and native, all based on HTML, CSS, and JavaScript. If you're interested in just the native stuff, you don't need to dive into Ionic altogether. You can look at Capacitor and try out those APIs in a very web-friendly way, but also get access to the native code when you need it. Framework, I showed this with Angular, but I didn't focus too much on Angular here, so you don't really need to worry about that. Angular, React, and Vue are the main ones that we kind of support out of the box, at least with Ionic. Capacitor's framework agnostic. You could use it with those big three or Svelte, Solid.js, whatever framework comes out tomorrow, pj.js, if that is something that you would like to make. Someone go npm squat that name. Either way, all these pieces together get you to the moon. They get you being able to build some cool stuff. So I want to thank you all for taking the time to listen to me today. You can follow me on Twitter at mhartington. I hope you're all taking care of yourself, making sure that you are staying healthy, safe, and mentally well. But thank you so much.